Hey everybody, this is Larry. This is day 25 of the Leak Code Daily Challenge in March. Hit the like button, hit the subscribe button, join me on Discord. There's a lot of clicking and loading and stuff like that. Yeah, I couldn't find my glasses. If you were watching yesterday, I don't know where my glasses are. So I'm just gonna continue doing that. But yeah, so I'm watching this watching. You're watching this live maybe now. I'm recording this live, so if it's a little bit slow, fast forward and all that stuff. Today's problem is word subset. Given A and B are words. But not okay. Maybe I didn't read it. B is a subset of the word A if every letter in B is in A. Okay, so yeah, okay. Okay. And it doesn't have to be in the right order though in this case. Does it have to be in the right order? No, it doesn't have to be in the same order. If for every A and a word A is universal for universal, if a word A from A is universal for every B and B is a subset of A. Return a list of all universal words in A. Okay. Okay, let me read this again in English. My reading is really bad today, sorry. Okay. So for every B is a subset of every A. Okay. Let's see. Let's look at the constraints. The constraints. I mean, to be honest, this is a fake constraint. I mean, it's not fake, but you can do it. You can. There's a easy compression to 26 characters, and then after that, you could do whatever you like. Probably linear. Yeah. So I'm just trying to think right now whether there's a clever way to do this. And I think there is, right? Because so there are a couple of ways to do it. I'm gonna go over it really quickly, so listen carefully because I'm not gonna actually type it. But you can slow it down or rewind if you need to. But yeah, the naive solution is just A times B, which is too slow. That's not going to cut it. Given that there are 10,000 and each word only has 10 characters or something like that. Yeah, and then the question is, okay, can we compress B, right? Well, for each B, we can go over an A, and yeah, and then the first thing you do is just using a dictionary, right? Or a counter, a frequency map, which maps, that's the first thing you process everyone, and then that compress 10 to 26. I guess it's not that much faster. But the key thing to note is that you can intersect all the B in a way. And the way that you intersect it is how do I say this? Like taking and you can kind of reason this out a little bit. You can take your time to reason it out. But the idea, I would say, and these are, I would also, just to be clear, these are observations that I'm making live. So, and I probably would have made it already, or I already had the ideas as I'm reading this problem. And it is not prepared. I didn't read this ahead of time. Though at this point, people sometimes ask me how many problems I've solved, and I probably am close to 5,000 or 6,000 problems in my life. Maybe more, maybe less. I don't know. I mean, at a certain point, how much can you count, right? So a lot of things are similar. A lot of things are familiar. So then you know these things, right? But yeah, but the thing to ask yourself is, okay, can we combine these words together in B so that we can do each word in A in a lookup time? Because if we could get this done in a constant E time, then that's gonna be fast enough, because then it's just linear in A, right? So then the question is, okay, well, we know that an obvious thing to do for each word in B is to compress it to a frequency map, and then the question is, well, can we combine each word in a good way, right? And actually, I think this one is a good one to illustrate it. Because then, okay, what happens when there are words or when there are characters that are overlapping, right? Well, you take the max of them, because here you only need one O for two of the words. Where here you need two O's because there's no one here. But let's say this word is YO. You still only need two O's. So then the the thing to do here is for each for each word in B, we take the maximum of the frequency count, and then from that we look at each word in A and whether those frequency count matches. And because you can do that in linear time, so linear means a couple of things. So I mean, everything is going to be linear, but it also helps to be more precise because there's the number of characters, there's the number of words, and then the number of characters, total number of characters, which is word times characters roughly, but they don't have to have the same length. So it's not precisely word times character, but it's just a sum of the characters, right? But I believe I have enough to go on. So let's play around with it. I'm going to use F for frequency. Let's use counter, though. Counter is just a shorthand. I get some questions recently about whether you should use counter in an interview. I would actually say no. I mean, like if you're on an interview, just use something that you can explain, something that people know, something like counter. And on an interview, I would use the hash table, and it's it's pretty straightforward. It's just for get, you do like get key and then default value or something like that, and then that's good enough for most people. But the reason I use counter is just it has a default value of 0 because it's a counter for any key, and I'm just a little bit lazy, to be frank. So actually, maybe let's do it. Let's call this B intersect. Right, this is the intersection of all the B's, and I like the other. And then for a word in B, we can calculate the map of. I think this works. I always forget whether that automatically gets it from each one character or not. So I always have to check because I don't know if it I don't. Well, okay, this is a bad example actually because they only have one letter. I thought there was 2 O's in this example. No, okay. Well, I guess this is also a bad example. Because I always forget. Well, I guess, actually, no, that works because I just worry that it takes a word at a time. So it's a little bit inconsistent, maybe. Maybe it's consistent because it's one word versus a list of words. Anyway, I'm bad at it. That's why I do it this way. But, and actually, I don't mean set, of course, I mean as a counter, and this is the frequency table, right? I actually wonder if there's an operation that does this. Like, what is beta? Oops. What does this do? But I would also recommend not doing something like that, but I'm just also curious about learning myself. So ignore me for a second and fast forward for a little bit. Okay, so I guess the intersection. No, we didn't want the intersection anyway. I was thinking of something else. Like not the union either. Like, so I guess you just have to write some custom logic. Because basically the idea is that, okay, for, what is the cleanest way to do this? Yeah, I mean, I guess it doesn't matter. Maybe we could do something like for character in f.keys, B intersection of C is equal to max of B intersection C or F sub C, right? We don't have to update F, so, and things that are already in B that are not already in C, then they don't get updated. So that's basically the idea, and there you go. You have the intersection of all the frequency map of all the tables, and we could kind of just print it out real quick to show you. This one I know about, but I just want to print it out just to be like, okay, for example, now there's 5 O's, 1 A, 1 E, and even though there's 2 O's in here, right? I might have to change it back just so that I know what the right answer is. But anyway, and then now we can do word by word, right? And then we have answer is equal to an array list, and then we can do something like F is equal to collections.counter of word, and then now we can do now we want the intersection, I think, and then the question is which. So this is the intersection syntax, but you can also write it out more directly, right? Or like, you could have just for loops to kind of calculate this. I would recommend it, and especially on an interview, because right now I'm just showing off a little bit Python syntax, and I would probably not recommend that. But yeah, if this is equal to B intersection. Yeah. Because what does this mean, right? That means that for everything in B intersection, F is a superset. If there's something that's in B, so, you know, the intersection of F and B intersection, if something that's in B and not in F, well, then you're missing, and then this will be false, right? So that's basically the logic here. For bitwise operators, I always forget the language and the order of operation, even though this is technically, you know, a little bit different. So I just want to, so I always do parens. Anyway, because I don't remember it. Then answer is append word. And then we can return answer. Let's give it some running code. Okay, that is the expected answer because I added way too many things. This is the, you know, montage version of the video. I hope that one day they bring the one button quick thing to the daily contest or daily whatever. Also, while I'm typing, while I'm doing this, I think I started last year in April because that's when the LeetCode daily thing started. So I'm almost coming up on 1 year of LeetCode, you know, thing. I'll probably make a special thingy for it, or not a special thingy, just like a post about it. Definitely, well, thanks for all your support throughout the year. It's you know, started as a pandemic hobby, and now look at us now, hopefully trying to get out of pandemic soon. Yeah, okay, let's see, is that good? That looks good, so let's give it a submit. Cool. And if you really want, you can actually, this could be a one-liner, this could maybe a one-liner. So yeah, you can definitely be really clever, be one of those like cool looking kids with the really short code. Though I have no interest as long as it's readable. I prefer if code is a little bit readable. But yeah, so what is the cost here? Well, for each, you know, for this counter thing, yeah, so this is linear in the size of the word, so that means that every character and every word will get looked at once by this collector thing. You can think about this as a for loop through a hash table and just incrementing it, right? So that's basically the idea here. Just to explain a little bit, you have this, then, you know, for C and word, f of C increment 1. Of course, you have to do an extra if statement if it's 0 and something like that, but that's basically what this is the shorthand for, and it comes in handy for some competitive stuff, but you do pay a little bit of a performance. And then here, you know, this is only going to be at most 26 characters, though also, I mean, it's 26 in that it can only have lowercase letters or 26 letters, but of course, the length of B is only up to 10, so this is even 10, right? So this means that this is linear as well in size of the total number of characters in B, and this is all of 1 roughly. I mean, this can actually, and also to be honest, this could be an array of 26 characters. I use counter because I'm lazy, and this as well, it could be an array of 26 characters. So this is, you know, you can make some judgment about hash tables and all of 1 lookups, but you can actually replace this with a 26 character array. So this is all of 1, right? So that means that for each character in B, we do O of 1. So this is going to be length O of length of B, right? And then in a similar way, this is linear in the size of all the characters in word. This is the only one that's maybe a little bit confusing to read, but as I said, you can unroll it to a set intersection, or, you know, frequency table intersection. But notice that F, of course, contains at most 10 characters, and B intersection also contains at most 10 characters. So this is going to only do, like, if you want to unroll it to a manual for loop, it's going to only have 10 operations. So that's linear, 1 for each character that's in word at most. And yeah, and then there's also a set comparison, which is also linear in the size of the word. So this is also in total O of length of A. So that means that because you have these two in series, this entire thing is going to be O of len of A plus O of len of B. And this is not just, I I mean, this is maybe a little bit confusing because it is a little bit confusing for me to write this way. This is not just 10,000. This is the number of characters. That means that each character is processed over 1 times in both A and B. So this is linear in the size of the input. And in terms of space, well, we actually kind of use constant space or O of alpha space, depending on how you want to define the size of the alphabet. Because as we said, this can be a 26 character thing, but that's also the max, right? You cannot have more than 26 items and be in the section, or this is 10 even, but you know, which is less than 26, as you know. So that means that we actually use constant space, or like I said, alpha space, where alpha is the size of the alphabet. Because if you're using a non-English or whatever alphabet that's more than or less than 26 characters, then in theory it could be more, but that's still O of alpha. You know, in this case, it's bounded by the number of characters. That's why the alpha doesn't necessarily come in. But you can also maybe make an argument that it's O of alpha, or min of alpha or characters. But in this case, it's always going to be the characters because it's at most 10. So yeah, so linear time, constant space. Let me know what you think. I think that's all I have. Hit the like button, hit the subscribe button, join me on Discord, and you know, you have a good day, you have a great night, have a good rest of the week, have a good weekend. Yeah, stay good, stay healthy, stay well, you know, to good mental health, and I will see you next time. Bye-bye.